Question 1. What is the primary goal of high availability (HA) design in cloud computing? Option A. To prevent any data loss whatsoever, regardless of the failure type. Option B. To ensure a system continues operating without any interruption during component failures. Option C. To minimize downtime and prevent service interruptions by eliminating single points of failure. Option D. To recover from widespread catastrophic events affecting entire regions. The correct answer is, quote, to minimize downtime and prevent service interruptions by eliminating single points of failure. Here's the explanation. As per the overview, the primary goal of HA is to minimize downtime and prevent service interruptions, thereby maintaining business continuity and a positive user experience. Question 2. To protect against failures impacting an entire data center within a cloud region, which HA design component is most commonly utilized? Option A. Single instance deployment. Option B. Multi-AZ availability zone deployment. Option C. On-premises backup. Option D. Manual failover procedures. The correct answer is multi-AZ availability zone deployment. Here's the explanation. The key features/components section lists multi-AZ deployment as crucial for spreading infrastructure across geographically distinct data centers within a single cloud region, protecting against failures impacting an entire data center. Question 3. In high availability HA design, what do RTO, recovery time objective, and RPO, recovery point objective, represent? Option A. RTO is the maximum cost of recovery. RPO is the maximum performance objective. Option B. RTO is the maximum acceptable downtime. RPO is the maximum acceptable data loss. Option C. RTO is the minimum time to failover. RPO is the minimum data to recover. Option D. RTO is the total operational time. RPO is the total data processed. The correct answer is RTO is the maximum acceptable downtime. RPO is the maximum acceptable data loss. Here's the explanation. The exam tips section clearly defines RTO as the maximum tolerable downtime and RPO as the maximum tolerable data loss, with HA designs aiming for very low values for both. Question 4. Which statement best describes fault tolerance in cloud computing? Option A. The ability of a system to minimize downtime, often tolerating brief outages during failover. Option B. The ability of a system to recover from catastrophic events affecting an entire region. Option C. The ability of a system to continue operating without interruption, even in the event of component failures. Option D. The ability of a system to handle increasing amounts of work by adding more resources. The correct answer is, quote, the ability of a system to continue operating without interruption, even in the event of component failures. Here's the explanation. As stated in the Operables overview, fault tolerance strives for zero downtime and continuous operation by proactively anticipating and mitigating potential failures, ensuring the overall service remains accessible and functional. Question 5. What is considered the cornerstone principle for achieving fault tolerance in a cloud system? Option A. Single point of failure. Option B. Manual intervention. Option C. Redundancy. Option D. Centralized logging. The correct answer is redundancy. Here's the explanation. The key features/components section explicitly states that redundancy, involving the duplication of critical components, is the cornerstone of fault tolerance. Question 6. When discussing recovery time objective, RTO, and recovery point objective, RPO, in the context of fault tolerance, what are the typical aims? Option A. RTO in hours, RPO in minutes. Option B. RTO and RPO, both very close to zero. Option C, RTO in minutes, RPO in hours. Option D, RTO and RPO both in days. The correct answer is RTO and RPO both very close to zero. Here's the explanation. The exam tips highlight that fault tolerance aims for an RPO and RTO that are both very close to zero, signifying continuous operation with virtually no downtime or data loss. Question 7. A cloud architect is designing a system that needs to handle rapidly fluctuating user demand for an online gaming platform. The primary goal is to ensure continuous availability and cost efficiency by automatically adding or removing compute resources based on real-time load. Which scaling approach is most suitable for this scenario? Option A, vertical scaling, scaling up. Option B, horizontal scaling, scaling out. Option C, manual scaling. Option D, over-provisioning. The correct answer is horizontal scaling, scaling out. Here's the explanation. Horizontal scaling, scaling out, involves adding more instances of a resource to distribute the load. It is inherently suited for fluctuating workloads, especially when combined with auto-scaling, providing high availability and cost efficiency by paying only for the resources actively used. Vertical scaling often requires downtime and has physical limits. Question 8. Which of the following is a primary disadvantage of vertical scaling compared to horizontal scaling in a cloud environment? Option A, it generally requires significant application code changes. Option B, it is theoretically near limitless in capacity. Option C, it often requires downtime for the instance to be upgraded. Option D, it is less cost-effective for stable, continuous workloads. The correct answer is, quote, it often requires downtime for the instance to be upgraded. Here's the explanation. The study material states that vertical scaling often requires a brief period of downtime to upgrade hardware or change instance types in the cloud. In contrast, horizontal scaling, especially with proper load balancing and auto-scaling, is typically seamless and zero downtime. Vertical scaling also has limits and can become expensive for top-tier instances. Question 9. An application relies on a single, monolithic relational database server. As the application's user base grows, the database experiences performance bottlenecks due to high CPU and I/O utilization. The immediate goal is to improve performance without a major architectural overhaul. Which scaling strategy is the most direct first step? Option A, implement database sharding across multiple smaller instances. Option B, increase the number of read replicas for the database. Option C, migrate the database to a larger instance type with more vCPUs and memory. Option D, deploy a load balancer in front of the database instance. The correct answer is migrate the database to a larger instance type with more vCPUs and memory. Here's the explanation. This scenario describes vertical scaling, scaling up, for a database. Upgrading the instance size with more vCPUs, memory, and faster storage is the most direct way to improve performance for a single, monolithic database without requiring significant architectural changes or code refactoring, as mentioned in the use case. Thanks for watching. Please subscribe to my channel.